Hi, my name is Shahram Kandaharizadeh, and I'm super excited about both disaggregated hardware and software systems. These systems hold the potential to transform today's obsolete practices to enhance efficiency by providing sustainable solutions. A key feature of disaggregated systems is that they do away with the old monolithic servers and database management systems. Emerging data centers disaggregate hardware into pools of resources and connect them using fast networks, such as the fast Ethernet or remote direct memory access, RDMA. The pool of resources may include FPGAs and specialized hardware such as Amazon's Trainium and Google TPU for machine learning, among others. Too many to try to visualize or list here. The software is also disaggregated into components and microservices that communicate using the high-speed network. This provides for software-hardware co-design. Moreover, it enables an intelligent agent to compose the microservices to realize new services. For example, an in-memory key-value store may be realized using a subset of components that implement a relational database management system. Assembly of components must consider the communication latency and use of caches to prevent this latency from dominating performance. Disaggregated systems will transform how we will approach provisioning of database management systems as a service. Instead of asking a user to size a server, we will ask, what is their desired performance objective? Now it is the responsibility of an intelligent agent to assemble the hardware and software to meet the application's performance requirements. With a high system load, the assembled system may scale up. With a low system load, the assembled system may scale down. Disaggregation also sets the data free without compromising privacy and security. Data engineers and administrators are paid to physically organize data to enhance efficiency and meet the performance requirements of an application. They make decisions such as whether the data is stored in a column format or a row format. However, many small startups do not have a budget to pay these experts. A disaggregated solution provides the services of these professionals, considering both a columnar and row store representation of data, along with alternative index structures by building the characteristics of a workload. Today's use of data centers by scientists, including those in the area of machine learning and AI, requires them to upload their data to a data center and run their computation in the cloud. This task requires scientists to answer questions such as what data to ship to the cloud, and whether their data is already in the cloud or not. As an example, NIH's National Library of Medicine has more than 36 petabytes of genomic sequencing data on 2 commercial cloud platforms. How is a scientist to discover and use this data? A scientist wants to know what is the minimum cost configuration for an experiment. They may have a fixed budget for running an experiment. Once the budget is exhausted, they want their result files and have the service shut down such that there are no additional expenses. They may also want to take a snapshot of their mid-flight experiment so that they can pick it up where it was stopped if the results are interesting. These are based on a report by the Presidential Science and Technology Council on AI R&D that was published in July. It describes the challenges of using commercial cloud providers for federally funded research in the area of AI. The report articulates a vision for a future system that reduces data movement and replication. One way to realize this is to extend the disaggregation to include a scientist's desktop. It provides for physical data independence, a concept pioneered by the database community, where the scientist is no longer burdened with the placement of the data. It is the responsibility of the infrastructure to manage data seamlessly with the final destination identified by the scientist. Typically, default is the scientist's desktop as the final destination. The concept of physical data independence may be applied to multiple data centers and many users whose desktop contributes resources. The processing and data placement may also be performed at the edge using the desktops. Thank you.